Ninth question. So read the question first of all. A bag contains 10 balls, out of which k are red and 10 minus k are black, and k is between 0 to 10. Right? If three balls are drawn at random without replacement and all of them are found to be black, then the probability of the bag that contains one red and nine black balls is, right? So it's a simple probability question. So let's check out the question. So what is given here? So suppose there is a bag, right? And the bag contains total 10 balls, out of which k are red and 10 minus k are black. Now, the question is like this. If three balls are drawn at a random without replacement and all of them are found to be black, already the balls are found to be black. That means the event has already occurred, right? Now, if the event has already occurred, now you need to find that probability that it come from the bag containing one red and nine black balls, right? So, it's clearly a Bayes theorem question. Okay. So depending on the context, what we can see here is here it is asking that probability that the bag contains one red and nine black balls is right. That means they are concentrating on the number of black and red balls. So let's take the scenario. So let me say there is a first there will be a minimum scenario of three black and seven red because already three black balls should be drawn, right? So already the event has occurred, three black balls are drawn, right? So that means minimum three black balls should be there. So or the bag can contain four black, six red, or five black, five red, or six black, or four red, seven black, three red, eight black, two red, nine black, one red, 10 black, right? So this is one possibility, one more, right? So if this happen from this probability one, I mean possibility one, then setting three black balls will be done like 3C3. There are three black balls, so 3C3, all three must be selected by 10C3. This is the probability from this possibility. From this possibility, 4C3 by 10C3 should happen. From this one, 5C3 by 10C3, and so on. Last one will have 10C3 by 10C3. As all are black, we can select any 3 by 10C3, right? So now the total probability of getting three black balls is total probability is 3C3 by 10C3 plus 4C3 by 10C3 plus and so on 10C3 by 10C3, right? So 1 by 10C3 of 3C3 plus 4C3 plus and so on plus 10C3. So it is of the form KCK plus KC K plus 1 CK plus K plus 2 CK. We need to remember this formula and so on. NCK, the formula is like this N plus 1 CK plus 1, right? So if you apply this formula over here, you are getting the total probability as 1 by 10C3 into 11C4, right? Now we need the probability that it came from this bag, which bag containing 9 black and 1 red. So the probability of this bag is 9C3 by 10C3, right? We need the contribution from this bag. So that means the bag contribution by total probability. What is the contribution of that one? So required probability is equals to the contribution of the bag 9C3 by 10C3 by total probability 11C4 by 10C3. So 10C3, 10C3 cancels out. The answer is 9C3 by 11C4. So we can calculate it. So which is 9C3 means 9 into 8 into 7 by 3 factorial, that means 6. 11 into 10 into 9 into 8 by 4 factorial, that means 24. Cancel it. 4. 9, 8. 9, 8 cancels out. 4 will have 2 and 5. So which is 7 to 14 by 11 5 is 55. So 14 by 55 is our required probability. Let's check out the options. Yes, it's fourth option. Done. Next, let's move to 10th question. What is given? If alpha beta such that alpha less than beta are the roots of this equation, One quadratic equation is given, right? Now such that 1 by alpha minus 1 by beta is 1 by 3, then you need to find sum of all possible values of lambda. So very simple quadratic equation question. So let's try to solve this. So the quadratic equation given is lambda x square minus lambda plus 3 into x plus 3 equals to 0, right? So let's say alpha beta are the roots. Here it is given 1 by alpha minus 1 by beta equals to 1 by 3. So what I can write is beta minus alpha by alpha beta equals to 1 by 3. So here clearly it is difference of roots and it is product of roots. It is difference and it is product. So difference between the roots, we already know the formula mod of beta minus alpha or alpha minus beta is root d by mod a, where d is discriminant and a is the leading coefficient. Now if you apply that, so what I will do is I will square it up because here square is there. So alpha or beta minus alpha whole square by alpha beta whole square equals to 1 by 9. So if I substitute the formula here, d by mod a square, d means discriminant of this quadratic expression. So that is b square, lambda plus 3 whole square minus 4 times lambda into 3 by a square. A square means lambda square into alpha beta whole square. Alpha beta means 3 by lambda, sorry, 3 by lambda whole square equals to 1 by 9. So this lambda square cancels out. 3 square means 9, 9 cancels out. So you'll be left out with lambda square. Here plus 6 lambda minus 12 lambda, you'll have minus 6 lambda plus 9 equals to 1. So that means lambda square minus 6 lambda plus 8 equals to 0. So this is the quadratic in lambda. So what is the question they were asking? For this condition to happen, you need to find sum of all possible values of lambda. So we got the quadratic in lambda. Let us say lambda 1, lambda 2 be the roots. So then sum of the roots is 6. So this is the sum of possible values of lambda. So the answer must be 6. Very simple, right? So 6 is the answer, first option, right? Let's move to 11th question. So it's clearly an integration question. Now we need to find the integration of this question. So let's analyze the question. 1 minus 5 cos square x by sine power 5 x cos square x dx. So here higher powers of sine and cos are there, right? And here I can see that here 5 and 5 are there. So what I can do is just I will separate this one like 1 by sine power 5 x into cos square x minus integration 5 cos square x by, I mean, if I can cos square x gets cancelled out, you'll get minus 5 by sine power 5x dx, right? Now, whenever there is an integration in terms of in two terms, right? Always focus on any one of the term, then focus on any one of the term and apply by parts. Okay. So if you apply by parts, automatically the other term gets cancelled out. Okay. So let's check out whether it's getting cancelled out or not. So I can clearly see sine power 5 here and here 5 by sine power 5x. So what I can do is I can convert 1 by cos square x as I'm concentrating only on this part. So 1 by cos square x, I can write secant square x, right? So what I will do is I will write it as secant square x, and 1 by sine power 5, I can write it as sine power minus 5 into x dx. So now I will take this one as our second function because it is easily integrable, and this one as our first function, which is easily differentiable. So integration of secant square x, you get tan x into sine power minus 5x minus, so write the tan x as it is. Now differentiate this minus 5 into sine x whole power minus 6 into cos x dx, right? So tan x in by sine power 5x, right? Minus, so tan x I can write sine x by cos x, minus minus it will be plus, 5 will be there, and sin x whole power minus 6 means 1 by sin x whole power 6. Now cos x dx. So this cos x, sin x cancels out. So you are left out with tan x by sine power 5x plus 5 times of 1 by sine power 5x dx. Now, if you observe, here we have concentrated on this part itself, right? And we end up with this one. Now you have to subtract, you have minus 5 of this one. And this one are same, so it will be cancelled out. So therefore, our integration is tan x by sine power 5x, which is taken as some f of x plus, right? Now you need to find f of pi by 6 minus f of pi by 4. So f of pi by 6 minus f of pi by 4 is nothing but, if you substitute pi by 6 here, 1 by root 3 by 1 by 2 power 5 minus 1 by root 2 power 5. So what you are getting here, 2 power 5, 32 by root 3 minus 4 root 2, right? So simplify it, 1 by root 3 form you have. So what I can do is 4 by root 3 I can take out. So you will be getting 8 minus root 6, root 2 into root 8 minus root 6, right? So that is nothing but our second option, right? Done. You get the answer. Very simple question, right? Let's move to 12th question here. Let f of x be a polynomial, such that this one is given for all x belongs to R. You need to integrate 0 to 3 f of x dx. For this to found, we need to find f of x, right? So for f of x, what is given? F of x square plus 1 equals to x power 4 plus 5x square plus 2 for all x belongs to R. So it's very simple question. You need to find f of x. See here, instead of x, we have x square plus 1. So what I do is let x square plus 1 equals to t. Then you will get x square equals to t minus 1. Substitute in the equation f of t equals to x square, here x power 4, that means t minus 1 whole square plus 5 times t minus 1 plus 2. So if you expand it, t square, here you get minus 2t plus 5t plus 3t plus 1 plus 2 plus 3 minus 5. So you have minus 2. So this is f of t. So we need to find 0 to 3 f of x dx. That means 0 to 3 x square plus 3x minus 2 dx. So let's integrate it clearly. So x cubed by 3 plus 3x square by 2 minus 2x. So 3 to 0. So substitute here. So 3 cube by 3, 9. You have 3 by 2 into 9 minus 6. So that means 9 minus 6, 3. 3 plus 27 by 2. So 27, 33 by 2. Right? The answer is 33 by 2. Done. Second option. Right? So again, then go for question number 13. Yeah, very standard question. So most of the, I mean, it's a 100% question in the PYQs. So let's solve this question. So how to find the area of this one, right? So it's a compulsory question in every question paper. Area question will be there, right? So let's try to find this question. So area of the region, you need to find this region and you need to find the area of that region, right? So let's understand what's the region. So here x comma y such that xy less than or equals to 8, 1 less than or equals to y less than or equals to x square, x greater than or equals to 0, right? So here, so first of all, see here. So xy less than or equals to 8. Whenever there is an inequality, always try to write first in the form of an equality, then you will know the nature of the graph, right? Xy equals to 8 means clearly it's a rectangular hyperbola, right? With the x and y axis as asymptotes. Let's plot that graph. So just plot a rough graph of that. So rectangular hyperbola. So this one, right? So xy equals to 8. And again, 1 less than or equals to y less than or equals to x square. So for this one, I will take y equals to 1. For this one, I will take y equals to x square. So y equals to x square means it's clearly a parabola, upward parabola, right? I will plot this. So y equals to x square is that particular parabola. Let's find it is xy equals to 8 and this is y equals to x square. Let's find the point of intersection of these two. So y equals to x square and this one. So if we put xy equals to 8 and y equals to x square, right? So what we can do, x cubed equals to 8. So x is 2. So this point of intersection is 2. So point is 2 comma 4. Right? Now if you plot y equals to one line here, y equals to one line. So let's plot y equals to 1, kind of like this. I'm drawing a rough sketch. This is y equals to 1. So this is our y-axis, this is our x-axis. Now all you need to do is you need to find the region. Here xy less than or equals to 8. So which region we can mark here? Either this region or this region should be there. But how to find which region is representing xy less than or equals to 8 means just take any one of the point here. Let us say I'm taking 0 comma 0. So xy less than or equals to 8 means substitute in the equation 0 less than or equal to 8. It is true. That means it should cover the origin. So that means it is representing this region xy less than or equals to 8. Okay. Next, here 1 less than or equals to, sorry, 1 less than or equals to y less than or y greater than or equals to 1 and x square greater than or equals to y. That means y should be greater than 1 and y should be less than x square. That means y should lie below y equals to x square and y should lie above this one. So that means this portion. So if you take the intersection portion of all these, I will mark the required region here. So the intersection portion of all this is this part. Now you can verify this part. So this is above y equals to 1 and below y equals to x square and in between xy less than or equals to 8, below this one, right? This is our required region. So you need to find the area of this region. So for this, let me find the point of intersection here, point of intersection of x square and y equals to 1. So this is clearly y equals to x square and y equals to 1 means x equals plus or minus 1. This is clearly 1, right? And clearly this is 2. Right. Now let's find the y equals to 1 and xy equals to 8. So that is clearly x equals to 8. So this is 8. So let's find the required area. So area is equals to from 1 to 2. This is the required area, right? So what I do is area equals to 1 to 2. Upper curve minus lower curve. Upper curve is y equals to x square minus lower curve. Lower curve is y equals to 1 dx plus again 2 to 8 upper curve minus lower curve. So y equals to xy equals to 8, y equals to 8 by x. So upper curve is y equals to 8 by x minus lower curve dx. So let's solve this integration to get the area. So it is x cubed by 3 minus x plus this is limits are 2 to 1 and 8 log x minus x 8 to 2. So if you substitute 2 here 1 by 3 of 8 minus 1 7 you get 2 cube and here minus 1 you get plus 8 into log 8 minus log 2, that means log 8 by 2 log 4 you get ln 4 minus 8 minus 6. So here 7 by 3 means 4 by 3 minus 6 plus 8 log 4. So you need to compare this one with yeah, so this values. So finally 8 log 4 minus 4 by 3 means minus 18 minus 14 by 3. Okay, so here 2 by 3 you can take out. If you take out 2 by 3, you have 4 log 4 minus 7 by 3. 4 log 4 minus, sorry, 2 by 3 we are taking minus 7. So what we can do is 2 by 3. Okay, So here you left out with 4, 4, 3, or you can take the LCM directly. So 8 log 2. So the options are in log 2, right? So we can do 16 log 2 minus 14 by 3. So if I take LCM, 48 log 2 minus 14 by 3. So if I take 2 by 3 common, so I will get 24 log 2 minus 7, right? So that is third option, 24 log 2 minus 7. Done. Let's move to 14th question then. So what is given here? Limit quotients. So limit expression is given. You need to find this limit, evaluate the limit. So let's go to the question. So whenever limit question is given, so limit questions are pretty easy. So first try to check the form. Okay. So here, if you see the form, here limit is approaching to 0, x is approaching to 0. If you substitute x 0 here, so 2 you will get, here you will be getting denominator as 0. So coming to the numerator, here x0 means secant 0, you have 1. Secant square, secant of e square into 0, again you have secant 0, 1. So every term is 1. So log 1 means 0. So it is of the form 0 approaching by 0 approaching, right? So 0 approaching by 0 approaching means we can use LH rule. So whenever limit is of the form 0 approaching by 0 form or infinity by infinity form, we can use LH rule, that is L'Hospital rule, right? So, but to differentiate it directly, it will be lengthy, right? So what I will use is, I will use the properties of logarithm. So log A, B, C, D, it will be log A plus log B plus log C, right? So this can be converted as sum, right? What I will do is, I will convert it them as sum. That means log of secant EX plus log of secant E square X plus and so on, log of secant e power 10 x whole by e square minus e power 2 cos x, right? Now it will be easy for us to differentiate now. So you can use a numerator differentiation by denominator differentiation. So 1 by secant ex into secant ex into tan ex. So if you do just to differentiate the first term, here you can clearly get e into tan ex, right? Similarly, you will have e square into tan of e square x. So we can directly write the numerator as like this, limit extending to 0, e tan ex plus e square of tan e square x plus and so on, plus e power 10 of tan of e power 10x whole by denominator differentiation. E square will be getting 0 and minus e power 2 cos x into 2 cos x differentiation is minus 2 sin x. So minus minus plus you will get. So like this. So here one more technique we can use to solve the limit very easily. That is, so whenever limit extending to a tan of something is there, so anything can be there. So if this extends to a, this argument tends to 0, then you can replace this one directly with this argument. That means we have the identity like limit extending to 0, tan x by x is equals to 1, right? So as x is approaching to 0 here, so I can say limit extending to 0, I can keep tan x as x. So if I use the same thing here, so what I can do is limit extending to 0. I can put tan of ex, instead of tan of ex, I can write ex, and here e square into e square x I can write, and so on, e power 10 into e power 10x whole by, and instead of sin x also I can write x, because limit extending to 0 sin x by x is 1. So can I write limit extending to 0 sin x as x, right? So if I substitute here, extending to 0 means this will be 1. So e power 2 I will get, and I can write this one as 2, right? Clearly x is approaching to 0. So this is x is making 0 in the numerator, and this x is making 0 in the denominator. We can cancel out that problematic term x, and you are left out with limit extending to 0, e square plus e power 4 plus e power 6 plus and so on, e power 20 by 2 e square. So clearly the numerator is a GP. So and 10 terms are there. So we can find the sum. So a into r is e square power n is r power n minus 1 by r minus 1 into 2 e square. And e square get cancelled out and you will be left out with e power 20 minus 1 by 2 times of e square minus 1. So this is our limit value. So e power 20 minus 1 by, so this one, third option. Done? Yeah.